Good morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with Everest Networks. We are welcoming back Mr. Ryan McKenzie. He'll be presenting today. He is their North American Director of Sales. If anyone has any questions, please feel free to submit them in the question box, and I'll ask them of Ryan at the end of today's presentation. Ryan, thank you so much for being with us again. Welcome back, like I mentioned, for your presentation, as the rest of us are. I am finished for now, so you can go ahead and take it on over.
Thank you, Julie, and thank you for everyone for taking the time and joining us today for this webinar. We appreciate Microcom and their hospitality, and they are a valued distribution and reseller partner of ours, and we appreciate the opportunity to be back again to work and present to them and their customers. As has been mentioned, today we're going to talk about multi-radio access points and really the evolution there. So the first part of this presentation will really be kind of a technology dive, and then we want to, towards the end of the presentation, take a few moments and talk about some of the Everest advantages that we offer in the multi-radio access point. So for the first few moments of this presentation, we are hoping to give you a quick overview of how Wi-Fi has evolved over the last few years and why now we have so many products on the market now that have multi-radios in the access points. And we'll talk about that more in detail as we go along. So thank you again very much for your time, and let's proceed. So first of all, an introduction. My name is Ryan McKenzie. I've been in the wireless and Wi-Fi world for about 17 years, doing outdoor Wi-Fi microwave point-to-point connections, as well as indoor propagation in hospitality, enterprise, and multiple other markets. I'm currently working with Everest Networks. Everest Networks is a fantastic company that has been around since 2014, but not many of you have actually heard of Everest because we've had kind of a unique start to our company. We originated as a doctorate program out of the University of Montreal back in 2012, and were then incorporated as Tembo Systems, after which we were actually invested in heavily by Panasonic, who is a partner of ours, and then rebranded as Everest Networks. And so for the first part of our life, during the development phase, we were known by a different name and actually didn't release a product until late 2016. Late 2016, we released our first product, and it was through direct sales and not through standard distribution. So we have actually a very mature product, but it has always gone through direct sales through Panasonic and not through the standard distribution channels. So our name is still relatively new to many of you. In 2017, we actually won our first NFL stadium deployment. So we'll talk a lot about how our technology works extremely well in high-density environments like NFL stadiums. But understand that that's just one application. The idea behind what we're going to be talking about today is that the type of challenges we see in an NFL stadium or in a basketball arena, a hockey arena, are the same exact challenges that are faced in convention centers, in casinos, in hotel convention areas, things like that. So anywhere where you have a high number of clients in a small area. So with that, let's jump in. I'm assuming that most of us on the call are wireless engineers, are Wi-Fi prognosticators, are in the Wi-Fi world and have followed the trends over the last few years. So I want to talk a little bit about the trends and about where Wi-Fi has come from and where it's going. We all know that Wi-Fi devices and wireless devices are becoming more and more prominent. In the article that I've referenced here, we see that North America is actually well above the average and is expected to have 13 devices per person by 2021. We've seen multiple articles over the last few years that have started with, most hotel clients are going to walk into a hotel room with 3 devices, and then it's 5 devices, and now it's 10 devices. And we know one thing for sure, and that is that every year more and more wireless devices are being released, and more consumers are using those and expecting to have them connected everywhere they go. So we've seen this evolution in the last 5 to 7 years where wireless engineers have had to modify their approach. It used to be that when wireless was introduced back in the late 90s and early 2000s, wireless was such a unique technology and was such a we'll call it a niche market that you really only had to provide coverage for an area. So on the left-hand side, you're going to see, you'll hear that term commonly in the wireless engineering world, and that's coverage versus capacity. On the left-hand side, you'll see a floor plan, and it used to be if you were asked to design a wireless network for an enterprise or for a hotel, maybe in the early 2000s or mid 2000s, then what you would do is put enough access points in there basically to cover the area, and that was all that you're really worried about, because the number of client devices that needed to connect to those access points were so sparse and so few and far between that the limit of the coverage of the AP was really your biggest limitation. We've seen the evolution that really started in about probably 2010 and has moved exponentially every year to now wireless engineers have to design for capacity. And so it has become much, much tougher now to design a wireless network that works efficiently, because now instead of designing just for coverage, in other words, having an AP that just covers a certain physical area, now we have to provide enough access points that will provide the amount of throughput to the number of devices trying to connect. Now, this is a picture that we want to come back to later on in the presentation. So remember these pictures. But what you see on the left is very simple, easy way to design a network. You can see only 6 access points, only 6 wireless network drops. On the right, we have a lot more. We have a lot more access points, which means a lot more wired drops, which means a lot more infrastructure to support that. Now let's talk about why this has become an issue. This all becomes an issue because we need to discuss how many clients you can have per AP. So someone that's brand new into the wireless world, they might not understand that there's only a certain amount of wireless clients that each access point can actually manage. So it used to be, here's a snap of a chat that was done just in 2015 on Spiceworks. Many of us in the wireless world spend a lot of time on Spiceworks, seeing what other professionals are doing. It's a great resource. And one of the common questions is, how many clients can I put on an access point? And you see in 2015, 25 to 30 per AP will give you good bandwidth on per access point. This is a standard rule of thumb that if you've been in the wireless industry for a number of years, we've heard that. I heard myself, 30 clients per AP is a great number to start with. Now, there's a lot of math that goes behind that supports that. But what we're seeing nowadays is that the rules of thumb don't suffice anymore, and you need to do a lot more research and a lot more planning in order to make sure that you have an efficient working wireless network. Luckily nowadays there's multiple capacity planners to help you with that. So not only do you consider the number of client devices, but also the amount of speed that they will each need, the types of applications that they're going to use, et cetera, et cetera. So all that now needs to be considered when you go into a new wireless deployment. Now, how does that relate to MultiRadio? Well, if we go back to this idea here, the coverage versus capacity. If you are designing a new wireless network and you have the ability to go in and put in new access points, on the left-hand side, it's very easy and very cheap to put in access points because you only have 6 drops. On the right, you're talking about increasing the infrastructure to support all that. This is one of the reasons that MultiRadio technology has evolved, and you started to see in 2013, 14, and so on, you started to see manufacturers release access points with multiple radios in one chassis or one box. Why did they do this? Well, because even though we're designing for capacity on the right, we'd like to actually keep the infrastructure that's needed to support the picture on the left. In other words, if I can only have 6 wired drops, but have the same type of capacity that I see on the right with that many APs, then that gives me the best of both worlds. I have the wireless capacity that I need without having the additional infrastructure needed to support that. So what you see is in the early 2010s, you started to see manufacturers and vendors start to create multiple radios, multiple radio APs. So on the left, for example, you'll see a standard access point that almost every manufacturer and vendor has, which would be a dual band or dual radio AP. This has been the de facto standard for a number of years now, where you have one 5 gigahertz radio and one 2.4 gigahertz radio. And it's important to understand that in this case, what we're talking about is propagation. So in propagation, we're talking about the radios that are used to connect to a client device. There are other radios that can be used for other things, for example, for meshing, for Internet of Things, for RF scanning. But here we're talking about just the propagation radios. So in the middle picture, you see that we started to see in 2010, 2012, we started to see different vendors come out with different chassis that were actually introducing more radios. And again, some of these radios were used for other operations, for example, meshing. So we can connect one wireless access point to another in order to prevent us from having to pull a wire. But what we're really wanting to focus on here is that propagation. And so as you are going around and evaluating, and really what I'm trying to do with this presentation is take the user on a journey. And that journey is, as you are exploring multi-radio technology in access points, what are some of the things to look for and what are some of the things to be aware of? A short introduction to the education needed in order to understand this multi-band and multi-radio technology that is now so prevalent in the WLAN world. So many vendors, for example, will claim that they have 4 radios, 5 radios, et cetera, but you have to read the fine details and see how many of those are actually being used for propagation to a client that my iPhone can connect to or my tablet can connect to, versus how many are being used for RF scanning, for wireless surveys, for WIDs or WIPs, for example. So you have to read the specification sheets very closely to understand what the manufacturers are doing. But it is safe to say that each manufacturer, for the most part, has taken their foray into multi-radio. When Everest decided to make a multi-radio access point, we had one goal in mind, and that was to solve the high-density problem that is seen in professional sports. And again, once we figure that out, it's very easy to apply that to other applications. So in every Everest high def or high density AP that we'll talk about a little bit more going forward, we include 4 radios for propagation plus a 5th radio for IoT. So we have a multi-band, multi-radio AP approach that gives you one 2.4 gigahertz radio and then 3 5 gigahertz radios. And then that IoT is another BLE, it's a Bluetooth radio, so it's another 2.4, but that is, again, is used for something other than the client propagation. Now, some of the challenges, and I wish that we could take more time. This is a topic that I would love to spend hours on, but we don't have the time to do that. So this is designed to give you a very quick overview of some of the challenges that we face when we start to talk about having multiple 5 gigahertz radios in one box. When we start to put, like we have here, 2 5 gigahertz radios or 3 5 gigahertz radios into one box, there is some major engineering obstacles that have to be overcome, which is why it has been such a tough evolution over the last few years. So to effectively use multiple 5 gig radios at the same time for that propagation, you need to provide separation. Separation and isolation is the key. So those vendors that introduced something years ago didn't have the separation or the isolation perhaps, and so you didn't have a true multi-radio AP. What you had is a radio that could broadcast and another radio that could broadcast at the same time, but you couldn't broadcast and receive at the same time, for example. And so you actually had a duty cycle where one radio was not working while the other one was. And so you don't really truly get the benefit. So when the engineering teams took upon this separation and isolation, it was all about making sure that we could take those 3 radios and making sure that they could broadcast and receive at the same time and give enough isolation and separation that the client would not see a difference. And so you'd actually see it as almost 3 independent access points. There's a couple of different ways to provide for this isolation. You can provide that by channel separation, using channels that are far apart on the RF spectrum. You can use radio separation, meaning different radios that are tuned specifically for those different channels. You can use antenna separation, and specifically, you can actually take antennas and, for example, on a tower, you can have them 3, 4, 5 feet apart from one another. That's one of the ideal ways to get separation. The only problem with that is most indoor access points don't give you that kind of leeway where you can take an antenna and put them 3 to 5 feet apart from one another to give you enough RF isolation. You've got to put them into a box that fits in a 11 by 11 box, for example, and fits in a ceiling. There's also bandpass filtering. Bandpass filtering is where we take and isolate specific channels on the RF side. And the RF is processed only for specific channels, so you cut off basically interference on the outside, similar to a bandpass filter on an audio system, for example. You also have digital filtering, which does much the same thing, and then antenna polarity. Now, as every vendor has kind of jumped into the multi-radio technology, this is not an exhaustive list, but this is a basic starting list of the types of separation needed in order to make a multi-radio solution work correctly. Each factor provides a certain amount of isolation. So a channel separation might give you, 80 megahertz of, if you use 80 megahertz of separation, that might give you 15 to 20 dB of isolation, for example. The idea is that each one of these factors is used to get to a total overall system isolation. Most vendors will use 60 dB as their benchmark. You can see a white paper that's referenced here that states that you need at least 60 dB of isolation to keep the receiver impact below 3 dB, which means that you can actually use those the multi-radios in a RX and TX or broadcast and receive at the same time. Remember that 60 dB of separation, because that will come up a little bit later. Now, the less separation factors used by manufacturers, then the more restrictions that the user has on using all 5 gigahertz radios at the same time. And this is something that's not understood by a lot of wireless users and wireless engineers, because marketing teams get involved and they start to write spec sheets that don't give you all the answers until you get the product in your hand. So, for example, if vendor A uses only 2 factors of the isolation techniques, then they may impose large channel separation or other limitations. So if you're only using channel separation or radio separation, then maybe they say, well, you have to use 160 megahertz of separation on your channels, and that means that you only have 2 5 gigahertz radios. You can't use 3, and you've got to have channels that are isolated 160 megahertz apart from one another. This makes your channel plan extremely tough to work with, because now you have a very limited number of channels that you can use at the same time. In fact, one vendor that uses this technique recommends that if you have a network deployment of multi-radio 5 gig APs in an environment, that you only turn on that second radio in certain instances. So you don't turn it on every access point. You maybe turn it on every other or every third access point. So you have some major limitations there. You're paying for technology that you don't use. There's another vendor, vendor B, for example, uses 4 of the isolation techniques. That gives you much more flexibility, but there's still some limitations. So, for example, if we're using these 4 isolation techniques, now we can have up to 3 5 gigahertz radios, but we still have a limitation that they have a large chunk of the RF spectrum that they can't use. So channels 132 to 140, a large chunk of that spectrum is unusable by that vendor. So at Everest Wi-Fi, we sought out to create a product that uses all of the isolation techniques. Right now, today, Everest is the only manufacturer Wi-Fi vendor that uses all of these isolation techniques and can provide up to 100 dB of isolation between 5 gigahertz radios. This has been proven out in lab after lab test, as well as in approval tests that needed to be done as well. So with our HD, our high density Wi-Fi, we have 4 concurrent radios that can operate all at the same time, both broadcast and receive. Now, because of the high-end nature of our antennas and our equipment that's used in order to achieve this, we have also software steerable antennas. We have advanced military spec hardware to reduce that interference. And we have our artificial intelligence in our software to help direct users and the coverage pattern as well. Let's talk about that a little bit more and what we do. So Everest uses specific radios and antennas that are designed for specific frequencies. In North America, we have the 5 gigahertz spectrum displayed here. We have the Uni 1 and Uni 2A, Uni 2C, and Uni 3. One of the issues that you see with other manufacturers is that they have, if they have 2 5 gigahertz radios or 3 5 gigahertz radios in a box, then they have an antenna that covers the entire band from 5.1 to 5.3. Well, you lose some of that isolation there, because if your antenna is actually able to broadcast or receive on any of those frequencies, then you don't provide isolation. So we actually have radios and antennas that are designed and specifically built for those frequencies, providing additional isolation that we need in order to allow you to use all of the multiple radios at the same time. In addition to that, and probably most important for the end user and something to look out for, is Everest right now is the only Wi-Fi vendor that allows users to use all of the 5 gigahertz channels. Now, this is in the North America 5 gigahertz bands, so each country is a little bit different. There is one exception to that, is that's channel 144, and that's just because of how the FCC classified that, how it sits between the Uni 2C and the Uni 3. Everyone has that limitation. Outside of that, Everest is the only manufacturer that allows you to use every channel. Other Wi-Fi vendors, as has been mentioned before, will say, well, you can use all of the channels here, all the 20 megahertz channels, but we have too much, we don't have enough isolation for channel 132 through 140, for example, so you're limited in your numbers. So this might be okay in a small deployment where you have a handful of multi-radio access points, but once you start to get into a large environment, we have a large number of access points. You need to, we all know that the channel reuse is extremely important. You need to have as many channels available to you as possible, which is one of the major challenges of any high density deployment. In addition to that, we have phased array antennas that give you pan and tilt software controllable coverage. So you can actually, with software, control the coverage area of the antennas to give you a spotlight coverage. In other words, we can maximize the RF coverage area in a specific area. That allows us to get longer range and higher throughput. And then in addition to that, we also introduce a new polarization that nobody else uses. So we have horizontal and vertical polarization, and while many other vendors go to a slant or a 45-degree polarization, we actually use an orthogonal polarization that allows for a third data stream. When you talk about high-density deployments with multi-radios, again, one of the problems that a lot of other vendors use, they use a traditional Omni AP. So we've seen this in the first graph that we saw between coverage and capacity. When you start to add capacity and you have multiple access points, if you don't have directional antennas, then the only way to really control that RF is either by physical barriers or by turning down the TX power. Well, that doesn't do anything for the RX power, and so the access points still receive a lot of the RX signal from the clients, leading to wasted energy as well as interference. Everest has spotlight antennas, meaning that we spotlight where that coverage goes, and again, can control that with software. That means less interference, more isolation, and more separation between RF channels, and that means faster throughput to the customer. Now, this is an example of what that brings you. So this is a actual image of a 3D model of a section of a NFL stadium, providing the 3 different beams that we have and the amount of control that we have, where we can actually isolate and control where one beam covers and where another one does not. Now, what has that done for us in the long run? So if we look at some of the laboratory tests that we've done, it all comes to throughput. In laboratory test after laboratory test, Everest is the only AP capable of delivering over 1 gigabits per second of throughput. That's going up against multiple radios, multiple APs from different vendors, and with all 4 radios broadcasting, receiving at the same time. We're talking about 1 client on each one. We can actually achieve over 1 gig throughput, 1 gig per second throughput. It's been proven that our product works. We have customer feedback that has been used in multiple large-scale environments, and we see again and again the reviews come back as the product works where other vendors have not. Now, lastly, to close out, I want to show just one difference in performance. There's some recent stadium installations. This is all publicly available knowledge. Sports Authority Field has 76,000 seats. They put in over 1,400 Cisco APs, some under seat, some overhead. Installation took about 8 months. Mercedes-Benz Stadium, about 71,000 seats, about 1,800 Aruba APs, again, under seat and overhead. Our initial installation into the NFL was the Philadelphia Eagles, Lakeland Financial Field. They have 70,000 seats. We only had 653 Everest APs throughout the entire property. There's only 220 bowl-facing APs. And yet with that, during a live event, we have been able to achieve throughputs that have not been met in other venues. So this is actual speed test, going to speedtest.net in a live environment where you've got full stands and you've got speed tests being run on iPhones. Lastly, at the bottom, you see a top 10, an unofficial top 10 for Wi-Fi events that's kept by Mobile Sports Report. A good friend of ours, and as you can see, they keep track of large venues and large data usage at large venues. And Everest Networks has 2 of the top 10, number 3 and number 6, and the only thing that's outdone us is the Super Bowl 52 and 51. So, as we like to say, the proof is in the pudding. It all comes down to, in a multi-radio environment, you need to have isolation, you need to have separation, and as you're evaluating and looking at different multi-radio vendors, make sure that you understand all of the isolation techniques that they use, what those limitations impose on you if you select to go with one that has less separation techniques. And so whether it's a convention center, a university lecture hall, a casino, a stadium, or arena, high-density Wi-Fi is a reality. We all know that. We all know that more devices are coming into the spaces that we're trying to cover, and multi-radio technology will continue to evolve because, again, from a cost perspective, from an infrastructure perspective, if I can go into a lecture hall that's pictured in the middle here and put one access point that has multiple radios inside versus putting in multiple radios and having Cat 5, Cat 6 drops to each one, I save on infrastructure, I save on installation time, installation money, long-term support, and long-term maintenance as well. Today, Everest Network stands as a leader in the multi-radio technology, and we plan on being that leader far into the future. And with that, I thank you for your time and welcome any comments or questions that there might be.
Thank you very much, Ryan, for that wonderful presentation. We enjoyed it very, very much. And it looks like I do have some questions here for you. Let's go ahead and get started with this first one. Is there a comparison chart available on your website that has the access points?
Yes, if you go to everestnetworks.com, listed at the bottom here, you can actually go to our product page, and on our product page, it shows the different access points, and it shows the comparison, the number of APs, the number of radios, the adjustable antennas, and the size of those antennas as well.
Excellent. Thank you so much. Next question here for you. Do you have a direct line for our team to reach anyone at Everest for any technical concerns? I mean, prefer it that way, or what would you suggest?
That is a great question. I'm gonna throw this out here right now. That the numbers that you see on the screen there, those are numbers that will get you to the general. We are putting together a support team right now that will have direct numbers as well. But I'm going to put out there. I'll give you my my direct number as well as my direct email. I don't know if you can maybe add to this, but I'll actually write it in the chat. But you can reach me anytime at 303-378-6677. And I can direct you to somebody that, if I can't answer the question for you. And then if you'd like to reach me by email, it's the same subnet that you see here, or domain, everestnetworks.com, but you put R. McKenzie in front of it, RMCKENZIE at everestnetworks.com, and I'll be happy to take any direct questions.
Excellent. That is noted. Thank you so much. Next question is sort of related to what you just said. If we have customers and let's see, can our customers call you directly, or would that be okay if they purchase product from us, sort of like a special priority support? Would that be okay with you?
Yes. Yeah, we are here to provide that support. What we would like to do is coordinate with the end user's sales rep. So we'd like to know where it was purchased from and who the sales rep is, so we kind of coordinate that. But yes, we do have support that is designed and able to take direct customer calls.
Fantastic. Thank you very much. Next question, and we may have asked you this last time, is Everest Networks developing or planning to have a community forum available so that those of us starting to work with your company and your products can get more and more and more familiar?
Yes, thank you for the request, because every time you request that, I put it up to the web team, and that gives them one more inspiration to get it done. So we have starting in 2019, we have our support line, as well as a forum coming online that will be on our website. So yes, look forward to that. It's coming. I apologize I don't have it yet, but yes, that's coming soon, and that will be a user forum that will be used for that type of support.
Excellent. That's very exciting to know that it's on the horizon. So thank you for that. A couple more questions. Let's see. Next one here. Does Everest Networks have any plans on releasing a downloadable app? Being able to manage the APs on the go is extremely convenient and ideal. What can you tell us about that?
Mm-hmm. Yes, we do. That is, I don't have an exact date on that, but that is on the roadmap. You will see that in the next year. We definitely will do that. So before that app is released, right now we have a software downloadable controller that you can put on any laptop or computer that runs VMware or VirtualBox, and that's how you can control it. But yes, the plan is to have a mobile app as well that you can do that with.
Fantastic. Thank you. We're looking forward to the various things that you're developing as we have more webinars with you throughout the following year, 2019 coming up. Can you tell us, Ryan, about where the products are manufactured? Can you give us some background on that?
Yeah, that's actually a very important question right now, and I'm guessing that there might be some reason why somebody would ask that, and I'll get to that. Right now, all of our products are manufactured. They are our products. We design, engineer them. They are our products and are manufactured in Taiwan. That is important right now because you're seeing from many manufacturers that with current U.S. economic limitations, you're seeing a price raise that's coming from a product that is being exported out of China. And we are not affected by that. So all of our products are in Taiwan and plan on being far into the future, so we don't see that price fluctuation that you currently see with other vendors.
Thank you very much. And yes, we've all had a discussion about that because it's happening to everybody. Ryan, thank you so much for answering all of those questions, and thanks for everyone for attending today. If there are further questions, please feel free to contact your sales rep or email us at sales@microcomtech.com. And if anyone wishes to view the products mentioned or shown today, please visit us at www.microcom.us. And remember, this webinar presentation has been recorded and it will be uploaded to our Microcom so you can view it again. Ryan, appreciate your time today. Excellent information. Looking forward to touching base with Everest as you evolve into 2019 and continue to have webinars with us. Thank you so much, everyone. Have a fantastic day.
Thank you.
You're welcome.